Hello everyone, this is the 14th week class. Today I'm going to introduce a method called PLS to you. Nowadays some people prefer PLS to Amos, right? I'm going to explain the difference between the Amos and the PLS. Also, I'm going to introduce a software called Smart PLS 3.0, and I'm going to show you how to use it. All right? Obviously, there are some differences between these two methods. So, for example, remember that in Amos we estimate model parameters so that the theoretical covariance matrix is equal to the observed covariance matrix, right? So we want to make this one as close as possible to this one, right? Remember that we create all kinds of equations, and we solve those equations in terms of the parameters, right? Now, in PLS, actually what the program does is to find the parameters so that some of the unexplained variation is minimized. Remember that in regression, we use the method called least square, right? So basically in PLS, program does a regression actually, right? So they use the least square method. So basically PLS does the regression, right? In Amos, we use the method called maximum likelihood, right? That's the big difference, right? And also in this case, we use covariance matrix, right? And in this case, just we use least square to minimize, this one, unexplained variation, right? So that's the big difference. And the second difference is about the assumption. In Amos, we need to assume that the variables have a multivariate normality. We assume that variables are normally distributed, right? In PLS, no distributional assumption is needed. That's a big advantage, right? In this case, remember that the bootstrapping? In PLS, bootstrapping is used, so we don't need a big sample, right? We only need a small sample, right? The third difference is about the sample size, right? In Amos, we need a large sample size. It should be around 200, right? In PLS, small sample size is okay. So, for example, 30 observations is fine. In this case, at least we should have 200 observations, right? Now, the fourth difference is about whether the program produces goodness of fit statistics, right? In Amos, we have goodness of fit statistics. Remember that the chi-square values and GFI and those things. Unfortunately, in PLS, goodness of fit statistics are not produced. That's a problem here, right? So no GFI index. Right? So that's a problem. And the fifth difference is about whether we have solutions, right? In Amos, sometimes we don't have solutions for our model, right? If the model is very complex, it is very difficult to solve those equations, right? That's the problem, right? Now, in PLS, solution always exists because basically we do the regression, right? So if you have independent variable and a dependent variable, you can always run the regression, right? So solution always exists. This is also a big advantage, right? The last one is Amos is used for confirmatory purposes to test the hypothesized model, right? So you hypothesize model and then you test your model, right? By using the Amos. But PLS is used for exploratory purpose to explore new relationships, right? So PLS is not that good in terms of testing the hypothesized model, right? If you want to check only whether your coefficient is meaningful or not, then in that case PLS is okay. But if you wanna test the overall model fitness, PLS doesn't give you the goodness of fit statistics, right? So actually you cannot test the overall model meaningfulness, right? So that's the problem, right? Those are the differences between the two, right? What I'm going to do today is to show you how to use the Smart PLS 3.0, right? So I'm going to use this model. This model is about the relationship between health consciousness and health status and quality of life here, right? This is the health status, and this is health consciousness, and this is one is quality of life. So health status is measured by two things, right? And health consciousness also is measured by two things, and quality of life is measured by three things, right? These are the indicators, right? You can examine whether this model is meaningful by using Amos, right? Also, you can use PLS for testing whether these relationships are valid, right? Remember that PLS doesn't produce the overall model fitness index, right? Let me show you how to use Smart PLS 3.0. By the way, this is free software, right? So you can download from a specific site, right? And remember that in Amos, you create a data set, right? By using SPSS, right? You can use raw data, or you can use a covariance matrix or correlation matrix, right? However, in PLS, you only use the raw data, right? And also you need to convert your SPSS raw data file to something called a CSV file, right? It's kind of text file, right? What you need to do is to create a raw data file with SPSS and then save the file as a CSV file. CSV is the extension, right? So when you save, you select file type, right? You specify the file type as a CSV, right? So that's the first step you need to do, right? The first step is to create new project, right? You click this one and let's type this one as test, right? So let's click OK. You see here your project is created, right? In order to use your data set, you double click this part, right? So you click this one and you select your data file. Remember that this one is a CSV file, right? So and you import, right? This one is your data, right? This one is a summary of your data. Okay. Now, in order to draw a graph, you select this one. Okay. So you have the empty space here. You are going to draw a graph here. And you see here, these are the variable names which appear in the your data set, right? So you are going to use these things, okay? So next step is to draw graph. You have three latent variables. So you click this one, okay? You click here, latent variable 1 and 2 and 3, right? You can move these things later, right? Now you are going to use the indicator variables, right, for the latent variable, right? So for example, stress, you click shift key and you click health and move this one to here, okay? So you are adding two indicators for the latent variable 1. And also you are going to move this one to here, two indicator variables for the latent variable 2, and you are going to move these three things here, right? This is the way to put your indicator variables to the latent variables, right? Now, if you wanna change the direction of this thing, click this one, select, right? And you click this one, and you click right button, okay? Here the align indicators right, okay? See what happens, right? So you can move this one to here, right? So you can change the direction of these indicator variables, right? Now you are going to add errors here, right? So you are going to click this one and you click here and you click here and click here. Once you connect these latent variables, the color changed, right? From red to blue, right? Now it's almost done, right? Let's name the latent variable 1 as HS, okay? So you select this one and you press the right button and you rename, okay? As let's say HS, health status, okay? And also you select this one and the right button and rename as let's say as consciousness, okay? And also you click rename and as quality of life, okay? It's done, right? This one is slightly different from the Amos in a sense that you are not going to add the correlation errors here, right? Remember that in Amos you put the correlations between HS and HC, right? Bidirectional errors, but in PLS you don't put those correlation errors, right? So it's done. So once you created this graph, you go to the calculate, okay? And you click PLS algorithm, okay? And then you start calculation, okay? So it's done. So you have this, and you click the graph here by clicking this. You see here, these are the coefficients, right? Coefficients, and this is the R square value here, right? Since we are, as I said, the PLS does the regression, right? So you have R square value here, and these are the coefficients, right? And if you wanna check whether these coefficients are valid, you go to the calculate, right? You select bootstrapping, right? So if you go to the graph here, right? In this case, these numbers changed, right? These numbers are the t values, okay? If you do the bootstrapping, PLS gives you the t values here, right? So basically, if your alpha is 0.05, you need to compare this one to the 1.96, right? If these ones are greater than 1.96, you reject null hypothesis, right? Null hypothesis is what? The coefficient is equal to 0. So rejecting null hypothesis is good news for you. But in this case, these t values are not greater than 1.96, right? So you cannot reject null hypothesis. In this case, these coefficients are not significant, right? So in this case, your model is not good, right? Unfortunately, right? So if you want to go to the original coefficients, right? So you click here and you click PLS algorithm, right? Then you have a coefficient value here, right? Here. So you have two things, right? Bootstrapping values and the PLS algorithm, right? So that's the basic step involved in the PLS, right? Now, I'm going to talk to you about a concept which is frequently used in statistics, but not many people know what the concept exactly is, right? The concept is called maximum likelihood. We have used this method for finding estimates many times, but I have not talked about what this method exactly is, right? So today I'm going to explain what this is, right? Now suppose that there is a jar which contains 100 balls. White and black balls are mixed, right? You want to estimate how many white balls there are, right? In order to do that, you take sample of size 5, right? Suppose that you selected 5 balls out of this jar. It turns out that there are 4 black balls and 1 white ball, right? Now, you can think of, in this case, 5 cases, right? The first ball is white and the rest of them are black. Or first ball is black and the second ball is white and rest of them are black balls, right? And so on, right? So you can think of 5 cases here. Now, suppose that the probability of selecting white ball is equal to P, right? And then you can compute the probability of happening of these 5 cases, right? It turns out that the probabilities are all the same, right? P times 1 minus P to fourth power, right? Now, if you add those probabilities, right, you can write it this way. This is called a likelihood function, right? So this is a likelihood function. So in this case, a combination, right? Combination is basically 5C1 is equal to 5, right? Now, using this likelihood function, you want to find P, which maximizes this likelihood function, right? So you plug values of P, this likelihood function, right? You can find the value, right? So you can draw a graph like this, right? Let's suppose that you have a p on the x-axis and you have a likelihood value on the y-axis, right? And then you plug numbers for p, and then you will get the likelihood value, right? And you draw a graph, and then you find p, which maximizes likelihood value, right? In this case, p star. This one is the estimate for the probability of selecting white. Okay, that's the basic idea here, right? The aim was to use the maximum likely method for estimating parameters for the structural equation modeling, right? Basically, what Amos does is to find parameters which makes, right, the estimated covariance matrix be as close as possible to the observed covariance matrix, right? So in order to do that, we need a likelihood function, right? So in this case, the Amos creates, right, something called proximity measure or proximity scale, right? Which is kind of a matrix form, right? So this one is the observed covariance matrix, and this one is the estimated covariance matrix, right? So proximity measure is a function, right? It's a function of these two things, right? If you see the this equation is kind of complicated, right? They use the matrix, right? And a term called the trace here, right? And anyway, so this is a kind of likelihood function, right? So you want to find the parameters or estimates, right, which maximize the this proximity measure, right? That's the basic idea here, right? So we are not going into deep in this case, right? Because matrices are involved here, right? All right, we have seen two different cases of using maximum likelihood methods, right? As we have seen, the basic idea is that you create a maximum likelihood function and find estimates which maximize the maximum likelihood function, right? All right, we stop here for today and see you next time.